Good day, everybody, and once again we're back together. I really saw this question from the September exam. It was a prelim exam from 2022, and I thought this would really make for an interesting preparation for for your exams. So if you haven't subscribed, please just make sure that you're part of the family. All right, and of course you can join in as a member. All right, so I just thought let's get right into this question. It's on Newton's laws, right? So let's dive into it. They say we've got two blocks of mass, which is 3 kgs and 8 kgs respectively. They're connected by means of a light inextensible string. Right, please note, once they say that, we know that that string will not form part of the total mass of the system. Right, and then they say the string moves over a frictionless pulley. Right, frictionless pulley means that, of course, the one side of the pulley, so if I've got tension here on the pulley, it should be the same as the tension on the other side of the pulley. Just please remember all of those things, right? And then they tell us that we've got a 3 kg block which is placed on a plane that is inclined at an angle of 30 degrees. Okay, they're talking about this guy here. All right, and in this case they are saying that a force of 55 newtons, which makes an angle of 15 degrees, okay, which is that force there, okay, is applied to the 8 kg block to move the system of blocks to the right. Now, that's very important because that tells us all of this system is moving in that direction. Please remember, ladies and gents, always choose the direction of motion as your positive direction. Okay, right, so they say the coefficient the 3 kg block experiences frictional force of 5 newtons. So we know this guy, as this is heading up, in this case it will experience frictional force of 3 newtons, right? So we know that friction here should be 3 newtons. 5 newtons, that is. 5 newtons. Okay, and they say the coefficient of friction between the 8 kg block and the surface is 0.16. So here we are given the coefficient of friction as 0.16. Right, so in both of the blocks there is frictional force that is experienced. All right, now let's look at the question. They say we should state Newton's second law of motion in words. I'm sure you know this off by heart by now. I even rode on a trolley. If you haven't seen that video, please go look at our shorts section and you'll see that I've stated that a law quite clearly. Right, 2.2, however, let's start with that. They say draw a labeled free body diagram of all forces acting on the 8 kg block, right? So now, when we're looking at the 8 kg block, right, what are the forces that would be acting in that particular system, or rather in that, in that block? So we've got the applied force, and please remember, ladies and gents, when we are drawing a free body diagram, please label the forces in full. So that's going to be applied force there. Okay. If you choose to write the acronyms, just please state what those acronyms stand for. So if you write FA, right at the bottom there, that FA is applied force. Right, so we've got the tension, right? So we know the tension in this case would be slowing down our block there. So that would be the tension on that string, or you can say tension force, right? But we also know that there will be frictional force, right? So we know in this case, this guy experiences friction. Okay, this thing is really acting up. Okay, right, let's remove that, and we've got frictional force there. Right, so we know we will have friction, force of friction. okay, we also will have the normal force. Remember, it is on a surface, a horizontal surface, so in this case, we know that the normal force will actually be vertical. Remember that normal force is perpendicular to the surface, right? And then finally, we know that we also will have the gravitational force that acts vertically downwards. Okay, so that will be a force of gravity. Okay, of gravity, or you can just simply say the weight of the object. Right, so please note that the amount of marks that are given usually should indicate to you how many forces there are there, right? Okay, so let's go on to the next question. They say calculate the kinetic frictional force on the 8 kg block, or that the 8 kg block experiences, right? Now remember, we're given a coefficient of friction of 0.16. So in this case, that's going to be the coefficient of kinetic friction, because we know that we're dealing with a system that is moving, right? So now, what we just simply need to do, ladies and gents, and please, I want you to note, for those of you who have not watched our videos, right, please do so urgently, right, on Newton's laws. So remember, when I look at that diagram, now I'm going to just redraw it for the sake of replacing that applied force there. Now remember that once we've got a force that is acting at an angle, that force has got components, right? In this case, we always say, well, we've got the horizontal component, we can call that the parallel component, whatever you want to call it. I'm going to call it, for the purpose of this, I'm going to call it the force in the x direction, right? And I've got another vertical component, which is going to be the force in the vertical component, right? I'm going to call it Fy. So remember, in this case, that Fx and Fy, so we've got a 15-degree angle there, right? And in this case, we note that the vertical component is actually opposite that 15-degree angle, right? So what we are going to do, ladies and gents, is that we know that if we want the vertical component, this is simply going to be the applied force F, right, multiplied by the sine of the angle of elevation, which is 15, right? And if we want that guy, this is simply going to be F, the cos of 15, right? Now what this does is that now what we're going to do is we can replace the applied force with the horizontal component as well as the vertical component, right? So this is going to be that Fy force there. Right, now note in this case we've got, there's our tension, so I'm just going to use T there. We have frictional force, okay, so we know that our frictional force in that case also acts in that direction, so that's going to be friction. Okay, so I'm going to just call it Fk, right, as well as gravitational force, which is Fg, that is acting there. Right, now, deliberately I'm going through this so that I can show you that we need to always resolve our forces, right, such that we only are left with vertical forces as well as horizontal forces, right? Please don't forget, we also have that normal force over there. Right, now where am I going with this? In order for us to calculate friction, we say it's coefficient multiplied by the normal force. So we need to find out what the normal force is, right? So in this case, we look at forces that are vertical, right? Why are we looking at vertical forces? Because the normal force is a vertical force, right? So it means that if I look at those forces, right, the sum of my forces that are vertical in this case would be equal to 0. Why? Because this particular block is not moving in the vertical dimension. So that will be the normal force plus Fy, right? And note both of them are moving upwards, minus the force of gravity, which is moving in the opposite direction. And all of these would give you 0. So to get my normal force, right, take these to the other side. Then Fg becomes positive and Fy becomes negative, right? So that means for a normal force in this case, that would be mass times gravitational acceleration, right? Minus, remember we said for that Fy there, right? That would be F, right? The applied force multiplied by the sine of the angle, which is 15. So let's just substitute what we've got. We've got the 8 kg block times 9.8 minus 55 sine 15, right? Let's find out what that normal force gives us. Okay, so I am going to have 8 times 9.8 minus 55 the sine of 15 degrees, and we get 64.1, well, let's just say 16. You can say 17 if you want to. That was 64, right? So that's 64.16 newtons. Right, so that means that to calculate the frictional force, that will be coefficient multiplied by normal force, and in this case that is 0.16 what was given, multiplied by 64.16, and I'm going to take that entire amount and multiply by 0.16. I get 10.27. Okay, so that's 10.27 newtons in this case, and that is our frictional force, right? So we've got the value of the frictional force on the 8 kg block. And then secondly, now they're looking for the tension in the string, right? That's connecting the two blocks. All right, now, so remember, now that we've got the, so we're looking at 2.3.2. Now that we've got, the free body diagram for the 8 kg block, remember it is moving horizontally. So now we are going to take the sum of forces in the horizontal dimension. And in this case, note that because it's moving horizontally towards the right, it means that my acceleration would therefore be to the right. And so my net force would be to the right. So we'll say for the 8 kg block, right? So F net would be equal to MA, right? What are the forces that we've got? We've got Fx, or you can call it F parallel, or you can call it, F horizontal, whatever designation you want to give, right? So that's Fx minus, in this case, the frictional force, right? Minus the tension, and that would give us MA, right? So we know this guy would be 55, the cos of 15 degrees. Remember, we said that would be the value there. So minus frictional force, we said that's 10.27. Okay, minus tension. Now, please note, in this case, our tension is unknown. That's what we want to get, right? And that would be equal to 8 multiplied by A. In this case, let's try and simplify this before we call it equation 1, right? So that's going to be 55, the cos of 15 minus 10.27. Okay, I get 42.86. Okay, and if you don't mind, I'm going to round off. I don't want to just keep this for very long. So that's 42.86 minus t is equal to 8a. Of course, in this case, I'm going to call this equation 1. Now, if you want to, you can already make t the subject of the formula. That's if you want. Okay, that would mean that now, if I make t the subject of the formula, t would be equal to 42.86 minus 8a. Okay, you can go that route. I am choosing to keep this one. Okay, now let's go to the other object now, which was the 3 kg block. Right, what are the forces that are acting on the 3 kg block? Right, note in this case, I know that the tension is pulling this guy upwards, right? But I also do know that there is frictional force that's acting downwards. I know there'll be, well, the normal force. We know we would also have now, note, we can have gravitational force, but remember, gravitational force on an inclined plane would actually be broken down into 2 dimensions again, right? So that would be the perpendicular dimension of gravity, so Fg perpendicular, as well as the parallel component of gravity, which is Fg parallel, right? Note in this case, to get those dimensions and the perpendicular dimension of gravity, just please remember this, ladies and gents, right? This is going to be mg, the cos of the angle of elevation, 30 degrees. For the parallel dimension, that would be mg, the sine of 30 degrees, right? Please keep that in mind, right? So there's a difference when I talk about a force that's pulling at an angle, and when I talk about, in this case, something an object that is on an inclined plane. And again, if you don't understand that, please just go and watch our videos on this particular section. Right, so I am going to say, right, now this is for the 3 kg block, okay? I am focusing on forces that are acting parallel to the incline, right? So what are those forces? We said that's the tension, that's friction, that's Fg parallel, right? That's tension, sorry, not tension, rather. That's friction, okay? So that would be the friction as well as that tension there. Right, so I'm going to say, right, for 3 kg, F net is equal to MA. And note, because we're using a string, an inextensible string, it means that the acceleration would be the same. So that would be tension minus Fg parallel minus the frictional force, right? And this would be MA. So that would be mass is 3 times 9.8, we said, multiplied by the sine of 30 degrees, minus the frictional force. Remember, they said the friction is 5 newtons, and this is equal to 3 times A. So let's just try to simplify. We've got 3 times 9.8 and 9.8, the sine of 30, okay, that's minus 5. So that gives me 9.7. So T minus 9.7 is equal to 3A, right? And that's our equation 2. Now, how I normally do it, ladies and gents, I just simply take equation 1 plus equation 2. But if you chose to make T the subject of the formula, you can now go and substitute for T over there, right? In my case, what I'm going to do is just simply take equation 1 and equation 2, right? I add them up. So my equation 1 was 42.86 minus T, right? So I take 42.86 minus T. That's equation 1, the left-hand side of equation 1. I'm adding it to the left-hand side of equation 2 plus T minus 9.7, right? And in this case, that would give me, then I add the right-hand side. That's going to be 8A as well as 3A. That would give me 11A when I add them up, right? Note what happens if you did things the right way. You should be able to get those T's cancelling out, right? What that would give you is the value of the acceleration, ladies and gents. Yes, I understand that's not what we were asked for, right? So I'm going to say 42.86. 42.86 minus 9.7, right? So that gives me that 33.16 there, right? I'm going to divide that by 11, okay, and divide that by 11. Oh no, yeah, so let's do this. Let's divide by 11, okay, right, and I get a value of 3.0, well, let's just say 0.1 meters per second squared. Okay, so that's the value that I get. You can verify if this is so. If I made a mistake, please do say so, right, on the comment section, but be polite, hey? You guys sometimes can go on attack. Right, so now that I want the tension, I can substitute this A value, right, back into any of the two equations. Then I can say, well, T, I'm going to substitute for A in equation 2. So substitute A in equation 2. And in this case, that gives me T minus 9.7 is equal to 3 times 3.01. Okay, and the value for T, okay, I'll take that value, multiply that by 3. Okay, I get 9.04, right? And I'm going to say plus 9.7. Okay, and I get the value of T to be 18.74. 18.74 newtons. Of course, anything closer to that would, obviously, if you did not round off as much as I did, or, you chose to round off at certain points where I didn't, of course, your value might be slightly different, but it would be around there, 18 newtons. Okay, right, and that is how the cookie crumbles, ladies and gents. I was asked by one of my students, during our online lessons, and they asked me a question, when do you choose to actually, add, the two values, right? So meaning, so when you've got the two equations, I chose to add, no, actually they were asking me, when would I, substitute the one into the other, or, substitute the one into the other. In this case, or rather equate the two equations. Yeah, actually that's what I wanted to say. So note, I could have made equation 2 to be equal to T is equal to 3A plus 9.7, right? This would be my equation 2. Now, because both equations, right, this one here and that equation are formulated by T, so I can actually now say equation 1 is equal to equation 2. So take, what I have here, 42.86, plus 8A. So that would be minus 8A rather. So I would say 42.86 minus 8A would therefore be equal to, if I made T subject of the formula here, this would be equal to 3A plus 9.7. And of course, you can now work out the value of A and do the very same thing that I did there. Right, ladies and gents, I hope that made sense, right? And of course, I'm going to keep giving you these random questions throughout the week in preparation for those of you that will be writing, and I know most of you will be writing your June exams soon, so please do look out for that. All right, from me for now, I'll see you guys next time. Don't forget to subscribe and like, and please don't forget you can be a member. Our NBT courses are there, all right, and you can get in touch with us at info@mlungisinkosi.co.za. I'll see you guys next time. Sharp, sharp.